In this video, we're going to learn how to apply factor and remainder theorem. So looking at the question, x minus 2 is a factor of this polynomial. When this polynomial is divided by x plus 3, the remainder is minus 50. So we have to find a and b, and we state the roots of the polynomial. First, this is the definition of remainder theorem. Okay, if you have a polynomial and you divide this polynomial by this, or is divisible by this, then if you substitute the value of x as a into the polynomial, then you get a value. The value that you're going to get is the remainder. Okay, so now we are told that x minus 2 is a factor of this. So in the last video we discussed what the factor is. So we can equally use the same idea here. So since x minus 2 is a factor, so what we're going to do is we equate this to 0. Okay, so we have x is equal to 2. Now since x minus 2 is a factor, it implies that f of 2 is going to give us 0. So that's what that means, since x minus 2 is a factor. So now what is the our polynomial? Our polynomial is 2x cubed plus ax squared plus bx minus 2. So now we then have to apply this. So we have f of 2. So this becomes 2 cubed so this is going to give us 16 plus 4a plus 2b minus 2 equals to 0. So this will automatically give us equal to minus 14. Okay, so which can be reduced to, this can be reduced to 2a plus b equal to minus 7. So let's mention this to be equation 1. That's, we are just applying what we did here is we apply this statement, x minus 2 is a factor of that. So which we use this relationship to get this equation 1 simply by substituting the value of x as 2 into this so that we can have that. Now let's look at the next statement. The next statement is talking about when this is divided by this, the remainder is 50. Using the same ideology, so we're going to apply remainder theorem for the second part. That is, x plus 3 is equal to 0. We equate it to 0, so we have x equal to minus 3. So now, if we put the value of minus 3 into the polynomial, and whatever we get is the remainder, which is, we are told that it is what? Minus 50. So our r is minus 50. So this is the relationship we are going to use. Or perhaps this is the rule we're going to use, minus 50. Because when we substituted the value of x as minus 3, this should be 3. We should get minus 50. That is what the statement means here. Okay, so having said that, so we now put the value of x as minus 3 into the polynomial, and the polynomial is actually, we have f of minus 3 is going to be 2 minus 3 cubed plus a minus 3 squared plus b times minus 3 minus 2 must be equals to minus 50, because that's the remainder. Okay, so the next is for us to simplify all of this. So this is going to give us minus 27 times 2, that's minus 54. Minus 3 squared is 9. 9 times a is 9a. Minus 3 times b is minus 3b. Minus 2 minus 50. Okay, so this can be reduced to, and minus 5 minus 54 minus 2 is minus 56. So we have to take this to the other side, becomes plus 56. So this becomes 6. We have 9 minus 3b. So which can be further reduced to simply by dividing everything by 3. So this can be further reduced to 3a minus b equal to 2. So let's say this is equation 2. So we're going to solve equation 1 and 2 together. So for equation 1, let me bring equation 1. So equation 1 is 2a plus b minus 7, because this is equation 1. Okay, so that's 2a plus b minus 7. Okay, 2a plus b minus 7. Okay, let me say this is equation 3. Okay, so what we do, we can add these two equations together. Okay, add it together. We have 3a plus 2a, that's 5a. This will give us 0, and a is going to be minus 5. Okay, so a is going to be minus 1. Okay, so a is minus 1, we can get b. So we can use equation 3. So b is going to be minus 7 minus 2a. Okay, which is minus 7 minus 2 times minus 1, because I just substituted the value of a as minus 1. That's minus 7 plus 2, and that's minus 5. So the first part of the question has been gotten, which is the value of our a is minus 1 and b is minus 5. So this now translates to the fact that the polynomial, which is 2x cubed, okay, plus a. Now a is now minus 1, that will be minus 1x squared, and plus bx, our b is minus 5, that will be minus 5x, and minus 2. So that's the polynomial. We've gotten the value of a and b to be that. So this is a polynomial. So the next question says that we should state the roots of the polynomial. So now, but first, we are given that the x minus 2 is a factor of the polynomial. We are given that x minus 2 is a factor of the polynomial. So then we can use, either we use the long division method or we use the synthetic division method. Either way, we are always good to go. So now let's use the synthetic division. So synthetic division, we have the 2 is a factor, sorry, is a 0 of that polynomial. So we just have to write out all the coefficients of this, or the constant, minus 5 and minus 2. So we have 2, minus 1, minus 5, and minus 2. So the first is to take this down. Okay, so we have 2 times 2, and that's 4. We're going to write that here. Then we add these two gentlemen, minus 1 plus 4, that's 3. Again, we have 2 times 3 again, and that's 6. Similarly, we have minus 5 plus 6, that's 1. 2 times 2 times 1 is 2. We write that here, and the remainder is 0. So, of course, this is the remainder because x minus 2 is a factor of the polynomial. So now we have to write the quotient. Of course, this is x raised to the power 3. So this should be x. It should be 2x squared plus 3x plus 1, which is the quotient. Okay, so now we know what to do. We just have to write the polynomial in that form. Since we have to solve this polynomial, now we have to write this in this form. That is, we have x minus 2. That is the polynomial. Is x minus 2 together with the quotient. Okay. So now it is now this that we're going to factorize. So we know what to do. This is a quadratic equation. We know how to factorize it. We just multiply these 2 times 1, and we say that this is x minus 2. We have 2x squared plus 2x plus x plus 1. So we have x minus 2, 2x, x plus 1, and what is common here? That's 1, x plus 1, and we have this. So we have x minus 2, 2x plus 1, x plus 1, and lastly we have x plus 1. So this is the factorized. This is factorized, and to solve it we just equate this to 0. So solving, we have x minus 2, 2x plus 1, x plus 1 equal to 0. Now we are ready to solve it. So now obviously we have x minus 2 equals to 0, or 2x plus 1 is equals to 0, or x plus 1 is equals to 0. So this becomes x equals to 2, x equals to minus 1 over 2, and s equals to minus 1. So these are the roots of the equation, the roots of the quadratic, the roots of the polynomial. Yeah, x equals to 2, x equals to minus 1, and equals to minus 1 over 2, and equals to minus 1. So, and we have completely solved this quadratic, this polynomial equation, and I hope you find the video encouraging, and don't forget to subscribe and like the video. Thank you.